Hello guys, this is Rachel from Third CSE and today I'm going to be explaining the sixth exercise in System Software and Compiler Lab. It is a generation of an assembler in SLC, one plus assembler in SLC. So I'll start off by explaining what an assembler is. So an assembler is a program that takes the basic computer instructions and converts them into patterns. Pattern of bits the computer's processor can use to perform basic operations. So assembler can also be called as these instructions can also be called as assembler language or assembly language. So having explained what assembler does, so I'll go on to the generation of the code. So all the the files necessary for this functioning are imported, and then input files are imported, and then what happens is we are going to create an output table, and we are also going to create a symbol table. So then using a buffer reader and buffer writer, there are two objects created for buffer reader and buffer writer, and we are going to get the program text into the reader and the intermediate text into the writer. So then we're gonna just start the functioning, and here the location counter is initialized 0 and start will also be initialized as 0. So while you read the first line, if it encounters start, then the title's length of it will be made as 3, and then the location counter will be marked as start. Else if the start is gonna be 0, then the location counter will be marked as start. And if the line contains any command in it, it means that the program has entered and made the line, the output, the symbol, and the location counter and writer object, everything, buffer writer object, everything will get stored into that of the symbol table for update in the symbol table. And then the location counter value is converted into a hexadecimal value. To find the length of this particular location counter, we are going to perform LC minus start, and we're going to assign LC is equal to start to whatever the value. So now this will have the length of the location counter. Next, we're going to close the buffer reader and the writer objects. So next is going to be to create a new buffer reader object called BR1, and this is the intermediate file. It will be read using this object. Then again, using a for loop, we're going to read this file, and then if the line contains start, then we're going to this stands for the header, so that will be converted into another hexadecimal value. And then this is for separation. This is for the separation, that the length is again whatever length that has been considered to the hexadecimal value will be written next. And next if the line while reading it contains an end, the integer value whatever is there, it will be converted, the start value will be converted into hexadecimal value, and it will be passed into an integer value. And then if either of these doesn't happen, then the location counter will again store the value of the line of table, the symbol table, LC and start. So next, the intermediate file, that is the object which read the intermediate file, is now closed. And the next is to convert this is for finding the length of the word. Next is to generate the parse2. So whatever we've seen till now is for the parse1, and next is the generation of the parse2. And so in the parse2, the input is going to be the hash table, the hash table for the output, and the hash table, the symbol table, the location counter, and also start. So what happens is, like while reading, if it encounters t, and then the location counter value will be converted into hexadecimal value, and it will be stored. And here, as you can see, this split is to separate the word. Whenever the split function is called, then the word will be separated into a different array. And so here, if the output table contains a key C of 2, and then the object code will become the object code plus the symbol, the separation symbol, and then whatever value we got for the word, like conversion of the word, and then the integer value will also get stored into that of the object code, and the location counter will be incremented by 3, and then the object code will be printed. Whatever object code is there will be printed. If that is not the case, then the line is said to contain a reserve word. Because it is a word, we will be multiplying it by 3, and if it is a reserve byte, it will be done by 1, so it is just incremented by 1. And if the line contains a word, then we'll increment it by 3. So this is going to be printed into the object code. The next one is the pass1 symbol table update. So while updating the symbol table, the pass1 will check for the symbols which are updated into that of the table. So the input is going to be the output table, the symbol table, the location counter, and the buffer writer, the object for the buffer writer. So what happens is like the string whatever is there will be split and will be entered into the array. So if the location C0 has and if the C1's location matches to any of the alphabets from A to Z, then it means that if the symbol does not contain the C, then you have to put the value of 0 into the 1, and then we're just going to enter 0 into 1. Else we're going to say that the label already exists. So this is just to check if all the symbol table has been defined in symbol has been defined in the symbol table. If it is already there, then you can just print it as the label already exists. Otherwise, you can be printing it as invalid label name. So next again, in the array, the C value that we split, if it equals to a word, then we're just going to put the location counter's value into C0, and we are going to increment the location counter by 3. If it is going to be a reserve word, then we're going to multiply the value in C, the second position of the C, with 3, and if it is going to be a reserve byte, we are just going to increment it by 1 because it is a byte, and then we have to prepare the this is for the generation of the opt table. So for that we're going to be creating an object for the new hash table, and then whatever is there in the this is the opt table dot text. So yeah, this is the optable opcode value for storing into accumulator, loading into accumulator, or storing into register, and so on. So this value is also being loaded, and it is being read from the optable text file, and then we're going to split this string again, and then whatever value we are just going to assign the values of whatever was there in the table. We are just going to assign the values correspondingly in the symbol table. So and finally it will return the opcode. So basically here in an assembler, what it does, like the program is converted and is sent to the intermediate table, and from there finally the opcode is the object table is generated. I mean the opt table is generated. So this is what happens in SIC assembler, pass1 assembler. So this is for my 6th exercise. Thank you for watching.